get into the final and talking about that. All right, so what I wanted to kind of show you, as I did show you this last time, is that you can do an integral by hand and you can also do it on your calculator, okay? Now, like on your final exam, I'm going to, give you directions, show work, okay? So you got to show work to get credit. But on a problem like this, you can also use your calculator to quickly check your answer. So we're going to do this one by hand and by the calculator. So what I've given you on this problem is this definite integral. Again, we call this a definite integral. That's different than indefinite integral, where you have the plus c. The definite integral is finding an area under a curve, in this case, between 0 and 10. So if you graphed out 60x minus 6x squared, you'd have a parabola, and we're finding the area from 0 to 10, okay? All right, so here's how you basically do this. Step one is you want to find the antiderivative. Okay, so we can do that. And antiderivatives, a lot of these things we only touch the surface of antiderivatives in a business calc class. So most of them you're going to do in your head. Okay, there will be a few use sub things also. Okay, so in your head, what you have is, first of all, how do you do the antiderivative of 60x? There you go, power rule, 60x to the second over 2. And then, of course, you could reduce 60 over 2. And, of course, the 6x squared is the same thing. That would be 6x to the third over 3. And then what you do is you put a vertical bar. This is a shorthand notation, and you're going to do this from 0 to 10. After you've done your antiderivative, the rest of this is arithmetic. So I'm just going to go ahead and write this as 30x to the second minus 2x to the third, evaluated from 0 to 10. So you get your antiderivative. And again, we have pretty much everything I've shown you on this section so far doesn't have to do with use substitution. It's stuff you can do in your head. Okay, now what you do is you evaluate. And what we're using is what we call the fundamental theorem of calculus, FTC. And what that tells you is it tells you the way that you plug in these limits. You always plug in the upper limit first. So what we're going to do is we're going to do 30 times 10 to the second minus 2 times 10 to the third, like that. Then you plug in the lower limit, and usually you really like it if there's a 0 there because it makes it a little easier. Okay, so we're going to plug in 0, so we go 30 times 0 to the second minus 2 times 0 to the third, and then you subtract in that order. Okay, so that's what the fundamental theorem of calculus says, is ultimately after you get the antiderivative, this is how you're going to get the precise area under the curve. Okay, and I'll do a lot of this in my head. This would just be 30 times 100 minus 2 times 1,000. And then the nice thing about all this stuff over here is that's a 0. Okay, that's why you usually like it if there's 0 in there, because you don't have to calculate as much then. So really what we would have is we would have 30 times 100 would be 3,000, and then minus the 2,000. So the area under this curve, represented by that definite integral, would be 1,000. Okay, so that's how you do a definite integral. You get the antiderivative, and you plug the limits in that order. Okay, is everybody clear with what I did there? Okay, all right. So let's do this on the calculator. I think I barely had time to show you this last time. So like on a final exam, if I'm asking you to do a definite integral, which I will somewhere, and then I would want you to show your work like that, but you have the ability to quickly check that you're right on the calculator, so I want to encourage you to do that. Okay, so go ahead on your calculator, and in Y1, just put in 60x minus 6x to the second, and set your window up so it's exactly the same as that graph that I gave you. So I'm going to press my window button. Now I'm not going to go 0 to 10, I'm going to go 0 to 11. There's a kind of an important reason for that. A lot of times what happens on an integral is if you stop at 10, not always, but a lot of times you'll get an error. That's just the way the calculator does that. So it's not a bad idea to go a little bigger, okay? But that just depends on the situation. And then I'm going to go like on the y, I'm going to do exactly like it says, 0 to 150. And they're scaling by 30 on that graph like that. So what we're going to do is just kind of reproduce the graph that's on there. Okay, so if you get everything put in, you can graph. And then what you do is I've got the keystrokes typed out for you on your handout. So you just do what's in this box. So what you do once you have your graph open, you go second, trace. Then you go all the way down to option 7. Option 7 has an integral. So fx dx, you press enter. It asks for the lower limit. The lower limit of the integral is 0. So you press 0, press enter. And then you do the upper limit, which is 10. And this is where it gets really cool. You guys even gave me a few oohs and ahs last class period when I did this. Now you press enter, it shades it in. There's your answer, 1,000 right there. Now that's cool, you got to admit. Okay, so it will basically be something that can help you to check answers and stuff. And in in engineering and economics and stuff like this, people do integrals numerically all the time, with computer software in the modern world. But you want to know how to do that and where that comes from. That's the idea. Okay, does anybody have any questions about what I did? Okay, all right. So let's do a few more definite integrals. These right here I'm not going to do on the calculator or anything. You could, though. So what we do is, again, these problems, you can do the antiderivative in your head. So what is the antiderivative of 9x? 9x squared over 2, good, okay. Power rule. Then you do your shorthand notation like that, okay. Then what you do is plug in the upper limit, so you'll do 9 times 8 to the second over 2. Then you plug the lower limit in, so that would be minus 9 times 0 to the second over 2 like that. And you could certainly use your calculator if you needed to, so this would be 9 times 64 over 3. This whole thing would become 0. Now crunch it out and make sure that you know it's 0. Sometimes students see 0 and they assume it's always 0. It depends on what the function is, of course. Okay. Where did the what? I have no idea. That it should be a 2. Thank you. Okay, so now what I can do is I could do this on the calculator if you want to. So I could go 9 times 64 and get that answer and then divide by 2. And that would give the answer to this integral would then be 288. That could be graphed. It could be checked the way I just showed you. Okay, you have the ability to do that. Okay, but those kind of integrals right here are fairly straightforward. Okay, business calc we don't get nearly as tedious as we do in a Calc 1 class. Just introduce the idea and also focus a little bit more on technology. Okay, this one's about as easy as it could possibly get. What's the antiderivative of e to the x? A to the x. Okay, again, you put your vertical bar 0 to 1. Okay, then it's just a matter of always do this in the right order. Plug in the upper limit, plug in the lower limit, and what you get is e to the first is e. What's e to the 0? 1. So that's your answer. That's the exact answer. Okay, we don't need to get a decimal or anything. That's the exact area under that curve. Okay? All right, so that's pretty straightforward. Any questions about that? So the only key thing that's different is you're learning how to do an antiderivative and use those limits to find that exact area under the curve. Okay? All right. Let's do one more of these, and I'll let you just do a couple of problems real quick. Then we'll do the u sub, which is a little bit harder. Okay, so what is the antiderivative of 1 over x? ln, absolute value of x. You do not put a plus c, okay, because this is a definite integral. So I see students do that a lot. I put the vertical bar, and then I plug this in like this. Plug in the upper limit. So you'd have ln of absolute value of 2 minus ln of 1. And, the absolute value isn't going to make any difference on this. What you end up getting is ln 2 minus ln 1. And if you're doing ln of 1, that really means log base e of 1. Do you know what that is? Is it e? It's not e. What do you raise e to get 1? That's what the problem means. 0. So the answer is 0. Now you could do on your calculator ln1 and you get a 0. Okay, that's kind of college algebra stuff. I like to just review that as that pops up a little bit. So what you end up getting is ln2 minus 0. And again, this is the exact answer right there. ln2 is the exact answer. You don't need to convert that to a decimal or anything. Okay? Okay, so I'm going to let you do these two problems at the bottom here. These are real simple antiderivatives that you can easily do in your head, and then just give me an exact answer. So I want to see if everybody can do this okay. Okay, so I'll give you a minute to finish this up. If you got your antiderivatives down in your head, then you'll be able to do these pretty quickly, I think. So does anybody have an answer to number 1? 4e to the second, what'd you say? There you go, 4e to the second minus 4 is what you should have got, okay? How about, I'm trying to do this in my head, how about the second one? 2 ln 5, right, okay, good. Okay, those are the answers, okay? All right, so here's what you should have done. The antiderivative of 4e to the x is 4e to the x. You're going to evaluate from 0 to 2. Plug in the upper limit to get 4e to the second, and then minus 4e to the 0. So that would be 4e to the second minus 4 times 1. We know e to the 0 is 1. So, yep, the answer would be 4e to the second minus 4. That's fine. You could factor a 4 out if you wanted to, but who cares? Doesn't matter. That's your exact answer. Okay? Now, this one right here, if you needed to do this, we have learned that you can pull constants out of integrals, but you don't have to if you can manage this in your head, which I think you probably can. So what you end up getting for your antiderivative is 2 ln absolute value of t, and then you're going to evaluate that from 1 to 5 like that in that order. Okay, so what you'll end up having is 2 ln of 5 minus 2 ln of 1. So you get 2 ln 5 here. And then ln of 1, again, you could use your calculator, but this really is just saying e to what power is 1, so that's 0. So you get 2 times 0. So the exact area under that curve is, 2 ln 5 like that. Okay? So those are pretty simple to do. Okay, that's a good starting point, is to be able to do the basic ones without much trouble. U substitution's more work, and that's what I'm going to focus on next here. Is we've learned how to do U sub, so we're going to work a little bit more with this, but we haven't learned how to do a definite integral yet. Okay? Okay, so this one right here, now you could not just do the antiderivative of this problem in your head. It's too difficult to do that. The thing that you probably want to do first, if you need to, is write this as ln t times 1 over t times dt. So I'd recommend you just rewrite the problem that way, and that will kind of help you to see how to set u. Okay, now remember, whenever you do du, you're hoping that it turns out to be what's left over in the integral. So any thoughts about what I should let u be equal to? Not 1 over t, ln of t, okay? So what we're going to do is we're going to set u is going to be equal to that piece right there, ln of t, okay? Now remember, du, don't look at your integral, just do it. The derivative of ln t is what? 1 over t, and then don't forget you got times dt. Okay, that's notational there. And what happens, this is the easiest type of u substitution there is, because everything's accounted for. We looked at one, I think, last week, before we actually did that test, of how to do that. So now this goes like this. What do I replace ln t with? U. What do I replace 1 over t dt with? du. Okay, it's a straight substitution. And then, can you do the antiderivative of u in your head? Yes, what is it? U squared over 2, right? Okay, u squared over 2. Now, here's what's different about the problem. This is the way that you should learn how to do this, is you've done the substitutions. Now what you should do is change the limits. If you do this, you make the problem simpler. There's actually two ways to do this problem. One way would be you could go ahead and get u squared plus 2 over c. Then you could plug the u back in to get ln t squared over 10. There's not a plus c because there's this is a definite integral. Then you could plug 1 and e in if you wanted to. But I don't do it that way hardly ever. There's an easier way to do it that'll make it even easier, okay? So that's what you're used to doing when you do u sub, is get your antiderivative, then plug u back in, okay? This is an easier way, okay? We're going to change the limits. So just write down e and write down 1. Those are the limits of integration. So what you do is you plug in to the u substitution that you made, okay? So what I'm going to do is that e is going to plug in to ln t, so we're going to work out ln e, okay? What's ln of e? 1, because you're asking the question, what power of e is e? E to the first is e, so that's a 1. Okay, we got that. Okay, now we're going to plug the 1 in. So we do the 1 in also. We do ln of 1, which is 0. Okay, now what you do on this now is these become your new limits. So in this u integral, don't use e anymore, use 1. And then don't use 1 anymore, use 0. So you've changed it into a type of integral that you just got through doing easily in your head a few minutes ago. If you change the limits of integration, it makes it easier. And you change the limits by plugging into the u sub. Does that make sense? Okay, so everything's accounted for. This is u, this is du, and then these things changed from 0 to 1. Does anybody have a question about how I did that? Yay, nay? Okay, all right, okay. Now let's finish the problem. So what's the antiderivative of u to the first? U to the second over 2. Now put your, your vertical bar, your shorthand notation. Now you're ready to plug it in. So the way you get your final answer is you'll have 1 to the second over 2 minus, and then you plug the 0 in, 0 to the second over 2. So you end up getting 1/2 minus 0. So the answer of this problem is 1 over 2. Okay, like that. Okay, so that's how that works out, and that's how that gives you the area under that curve from 0 to 1. Okay, any questions? Okay, let's find out if we're right. Okay, suppose you're doing this on a final exam, and you want to know if you're right before you leave. Okay, here's all in the world you'd have to do. You can do this with me, or you can just watch this if you want to. Okay, so I would go all the way back to the original problem, and I would graph ln, and you'd have to use x, of course, ln x over x. Okay, we're going to graph that. Now, you could do this in a standard window if you wanted to, or you could redo your window if you want to. I'm just going to go standard window, just real simple. Zoom 6. Okay, that's what that function looks like. Okay, now what I'm going to do is go second trace, option 7, like I showed you, put in the lower limit of the original integral, which is 1, put in the upper limit of the original, which is e, and e is right above the division symbol. Go like that, press enter, it'll shade it, and there it is, 0.5, that's a half. Okay, it took me like less than 30 seconds to verify that I'm right. See what I mean? Okay, so you got the power to do that. You don't have to really worry about doing a window. As long as the graphing calculator gets the right function in, it's going to do it okay, generally. Okay. All right, so that's how you do that. Any questions about what I did? Okay, that's a little bit more difficult on U sub. So I'll do one more, then I'll let you try to do one, and then that'll kind of wrap up what we want to do here now. Okay, so this one's probably a little harder now still. This is probably about as difficult as it's ever going to get in this class anyway. Any suggestions about what I should set U equal to? U squared plus 1. I've heard several people say U squared plus 1. Let's try that out and see if that works well for us. Okay, so we're going to let u be that, and see, you can kind of put your integral together as you do that. Right now we'd have u to the 7th, which we can handle. We know that antiderivative of u to the 7th is u to the 8th over 8. Okay, don't look at the integral. What is du? What's the derivative of x squared plus 1? 2x times dx. Okay, now here's what happens on this, is this thing does not match that. Now, there's a couple of ways you can make it match. There is a couple of ways that you could do this if you wanted to. Here's one way. This is a little sneaky, but you could do this. Isn't 32 just 16 times 2? So a person could go 16 and 2 like that on your integral. You don't want to change that yet, but what you could do is you could change this to 2x and have a 16 in front, and then x squared plus 1 to the 7th dx. Sometimes you can do stuff like that. So what happens is we got u, and now we've got du. So that's one way to do it. Sometimes you can work with the constants and do it that way if you want to. Okay? Not always, but sometimes you can. Okay? All right? So now what I'm going to do is when I put this all together, I'm going to have 16, and then this part right here is going to be u to the 7th, and then the 2x dx is going to be du. So I've got everything accounted for except I haven't changed the limits yet. Okay, but the 32 could be changed into 16 times 2, so you can match that up. Okay, now let's see. We're going to write down our limits. We have 1 and 0. What do you do with the 1 to change the limit? Where does it go? Into the u sub. Okay, so plug it in. So you'll have 1 to the 2nd plus 1. That's equal to 2. So what happens is that is no longer 1. That is now 2. The upper limit is 2. Okay. Then we can do the same thing with 0. Plug the 0 into the u sub. You'll have 0 squared plus 1 is equals 1. So again, don't use 0 anymore. Use 1. Now see, the goal is really when you do u sub, you've accounted for everything there is in the integral. I did. Everything's done. Now I've got a very easy problem to finish up. Okay, any questions? Okay, all right, so now here's what we do. The 16 is a constant, it comes down. What is the antiderivative of u to the 7th? U to the 8 over 8, and then we're going to evaluate that from 1 to 2. Now, it would be wise to just simplify that 16 over 8 to 2, so you'll have 2u to the 8th evaluated from 1 to 2 like that, okay? Then we would be ready to evaluate and get the answer to the problem. So you plug the 2 in. So you have 2 times 2 to the 8th minus, and then plug the 1 in. 2 times 1 to the 8th like that. Now you can do it that way. You could also, just factor out or ignore that 2. You can do this usually the way I do it, just do it like that. Okay. You could always take out a constant if you wanted to, but you don't have to because you're going to do this on your calculator anyway. Let's see, 2 to the 8th, I don't know, 512? That's a bad guess probably. Is that right? It is right? Okay, all right, better than I thought it was, okay. So that would be 2 times 512 minus 1, so that would be 2 times 511. So that would be 1022 should be the answer to that integral. Okay, that's your area under curve. It could certainly be checked and everything. Okay?
No, 2 times 2 to the 8.
Oh, hold on. What's that?
2 times 2 to the 8 is 512.
2 times what?
Oh, from the original part, where it's 2 times 2 to the 8.
Oh, the whole answer was 512?
Yeah.
Oh, okay. All right. That seemed a little weird to me. Okay. Okay, so when you got the final answer on this, I guess, what I was asking, I was trying to think of what 2 to the 8th power was, and I wasn't sure what that was. So what is 2 to the 8th is, that's it, 256. Okay. So then you got 2 times 256 minus 1, I see. So that's 2 times 255. So that is 510, right? Okay. So that should be 510 would be the final answer to that problem. Okay. Okay, any questions about that? And you know, you can, when you get down to that final step, you can put that in your calculator. You could just go 2 parentheses 2 to the 8th minus 1, because you can do 1 to the 8th in your head, and you can do that okay. Okay, so let's, I'll let you try this problem, which is quite similar to what I did, and see if you can do that okay. What do you think you would set u equal to? X squared, okay, so I'm just going to do that, and then the rest of it, try it and see what you get, okay? And this will end up, when you do du, it won't match what's left over, so you could do a similar thing on this problem to what I did if you wanted to. And if you want to check your answer, you can certainly check your answer on this. You could just graph it in the standard window, and it probably would work just fine. Again, with this, give an exact answer. Your answer will have an E in it, I think. So I just kind of see how it goes. So I'm going to kind of walk around and see what your work looks like on this, because this is probably about as challenging as the definite integrals are going to get in this class. Yeah, that's right. That's right. That's what I got. Okay, that's good. You broke the 10 up into 5 times 2, so you're doing that correctly. Okay. And your limits are changing 0 to 4 now. Okay. And then you're going to have e to the u, e to the u, du, e to the u, du is what you're going to have. Limits are going to change 0 to 4. Okay. Now, that right there, see you end up with 2x dx. Mm-hmm. The original integral had 10x dx. So you could write it as 5 times, and I see you took your 5 out, but that right there is going to be just du now. But see, 2x dx is going to become du. So you end up with the integral of e to the u du, with a 5 in front of it.
Times
e to the u du. Yeah, because when you do your substitution, the 2x dx becomes du, and then the other part becomes e to the u. Okay. Okay. Now then you just need to change that, so that's from 0 to 4. So you've now got this correct, so you're okay now. So now you finish it up and you'll get a right answer. You're doing all right. Okay. That's right. Hold on. That's not quite right. The limit should go from 0 to 4. So you have 0 to 4. You did that right. You can split it. Okay, so the limits, is that a 0, 0 to 4? Okay, now, the antiderivative of e to the u is e to the u. You're thinking of a power rule. Yeah. It's not a power rule. If it was like x to the power, if it was like u to the 10th, then it would be a power rule. Okay. That's right. That's it. So I think what you should get is 5 e to the 4th minus 5 would be one answer. You could have 5 times parentheses e to the 4th minus 1.
It was like 5 because we.
That's what I got.
So 10, right? Yeah. We can 5 times 2x, right?
All right. Well, you kind of missed something.
So then.
So then I just raised it to u because that's what I'm.
So the way this goes now now is that you
Oh, this
change the
becomes E to the
limit.
U, yeah.
Two plugs in there.
Oh, you changed it,
And
okay.
you do the
Okay.
second, so you get 4. 0 is a limit of integration, so you plug that in, you get 0 the second equals 0. Yeah, so the new limits are 0 and 4. See, everything gets plugged in.
I know, like,
That
the first one
limit
that
is
you did was.
because that's what you set in.
Understand.
And then this, we ended up with 2x dx. So what you have to do is you have to change this to 5 times 2x dx before you do your substitution. Okay, so you're going to have e to the u and then 2x dx gets replaced with du. The reason I put that 5 there is because I ended up with 2x dx. 5 times 2 is 10. I have to have a 5 there, that way I don't change the problem. Antiderivative of e to the u is e to the u. So you're going to just say 5 e to the u. Then you plug in the upper limit, the lower limit, correct. So you have 5 e to the 4 minus 5. Okay. We have talked about that in last class. Okay. I'll run it through today. Yeah, yeah. Yeah, just, you probably wanted to, I can't send you anything. Because I know you just class and that might help you. All right. I posted on D2 while we're in. It's Monday, Wednesday, so it's Monday, 8:30 to like 10. Cherry Creek 163 on D2. Under your situation. Okay, all right, so look, I did pretty good. I think keeping track of all the substitutions is usually the biggest thing here. So du is 2x times dx. And the way I kind of look at this is, well, we've got the x squared accounted for. But again, what happens on this is it didn't match. So 2x dx, we ended up with 10x dx. So what you can do, a simple way to handle this situation, is really just change this original integral to 5 u to the, this is before I do the substitutions, and then change that 10x to 5 times 2x, e to the x squared dx. That way everything matches, see, okay? And what you'll have on the limits, you plug the 2 into the u sub, so you do 2 squared to get 4. Then you plug the lower limit 0 in to get 0 to the second, so that's equal to 0. Okay, now what you have to do is you have to just kind of take care of all your substitutions. Okay, this may be one good way to do it. The 0 is still 0. The 2 changed into 4, so our limits are different now. That's a pretty simple thing to do. And then this part right here is going to become e to the 0, and then 2x dx, well, that's what du is. Okay, so what you end up with when you get your integral is you end up with 5 times the integral 0 to 4 of e to the u du. The hardest part for most students is getting all the substitutions taken care of. So we replaced x squared with u to get e to the u. 2x dx is what du is. Now we have that 5, we had to kind of deal with that 5. Okay, do we have a question on that? Okay, now when you finish this up, you're going to have the 5, and then you plug in upper limit, and you can go like this. You can just write the 5 down and have a parenthesis if you want to. So you'd have e to the 4th minus e to the 0. So one way to write this answer is 5 parentheses, e to the 4th minus 1. Okay, some of you did it like this, which is also okay. You just have 5e to the 4th minus 5e to the 0. That's going to give you the same answer. Just going to give it not in a factored form, so it doesn't matter. Okay, so that either this answer or 5e to the 4th minus 5 would be a correct answer, because e to the 0 is going to give you 1 anyway. Okay, so that's how that goes, and then that one could be checked on your calculator. Okay, all right, we have any questions? Okay, well, we did pretty good. Now I'm going to, on the final exam, the last thing, and you could get by without learning this. I wanted to teach this to you before we take a break. And again, you're not going to turn notes in. I'm just going to take this copy here and go over a couple of examples, because the extra credit problem on the final would be with this kind of problem, which is easy to learn. I just give it on extra credit because we learn it so fast at the end, okay? And that's kind of the way I sometimes do some of the extra credit, and you can learn to do this totally on your calculator. Okay, so it's a fairly easy thing to learn. So we'll go ahead and go through a couple of examples on that, and then that way I've got everything in that I was required to teach you this. Okay? So this will be this is just kind of one basic application of definite integrals. So I'm just going to run through a couple of things on here. To finish this up now.